Part 1. What is K2-18b? Approximately 45-60 seconds. Background music, calm and curious tone. Host, friendly, informative tone. So, let's start with the basics. What exactly is K2-18b? K2-18b is an exoplanet, which simply means it's a planet that exists outside our solar system. It's located about 124 light-years away in the constellation Leo. This planet orbits a red dwarf star, a smaller, cooler type of star than our Sun. But here's where things get really exciting. K2-18b lies in what scientists call the habitable zone of its star. That's the Goldilocks zone. Not too hot, not too cold. Just the right distance for liquid water to possibly exist. And K2-18b isn't your typical rocky planet like Earth. It's believed to be a Hycean world. That's a relatively new term scientists are using for exoplanets that have a hydrogen-rich atmosphere and might be covered by global oceans. Imagine a hot, steamy ocean world wrapped in thick clouds of hydrogen gas floating in deep space. That's what K2-18b might look like. It's also way bigger than Earth, about 2.6 times Earth's radius and nearly 9 times its mass. So it's somewhere between a super-Earth and a mini Neptune. Too big to be just like us, but not so big that it's completely hostile. And because of these unique features, oceans, hydrogen atmosphere, and being in the habitable zone, K2-18b has quickly become one of the top targets in our search for alien life. Visual fade out to text. But what did the telescope actually find? Part 2. What did the James Webb Telescope find? Approximately 60-75 seconds. Background music builds. Scientific, futuristic vibe. Host, excited, informative tone. Alright, so what's all the buzz about? What exactly did the James Webb Space Telescope, JWST, detect on K2-18b? Using its ultra-sensitive infrared instruments, JWST looked at how the light from K2-18b's star changed when the planet passed in front of it. A method called transit spectroscopy. This light passes through the planet's atmosphere, and molecules in the atmosphere leave fingerprints in the spectrum, helping scientists figure out which gases are present. And here's the headline. They found methane, carbon dioxide, and most surprisingly, dimethyl sulfide, or DMS. Why is that a big deal? Because on Earth, DMS is produced almost entirely by marine plankton, tiny ocean-dwelling life forms. So if it's truly there, it could be a potential biosignature, a chemical hint of life. The methane and carbon dioxide combo is also intriguing. These gases together, in the right ratios, might suggest biological processes, especially on a Hycean-type planet. But, and this is important, the DMS detection is still preliminary. Scientists are reporting a 99.7% confidence level, also called 3 sigma, which means it's likely but not conclusive. Still, even a hint of DMS on an oceanic exoplanet? That's enough to get every astrobiologist on the planet very, very excited. Visual fade to black with text. But wait, is this really proof of life? Part 3. But is this proof of life? Approximately 75-90 seconds. Background music shifts, more serious investigative tone. Host, calm and critical tone. Okay, let's take a step back. This all sounds incredible. But does it mean we finally found alien life? Not quite. And here's why scientists are being very, very cautious. The DMS detection is at 3 sigma confidence. That's about 99.7% certainty. Now, that may sound huge, but in scientific discovery terms, it's not enough. Researchers usually look for 5 sigma, or 99.9999% certainty, before calling something a confirmed result. Think of it like this. 3 sigma means there's still a 1 in 370 chance the signal is just noise. That's a big enough gap that we can't claim it's real, yet. Plus, there are some weird gaps in the data. For example, scientists expected to find ethane, a gas that usually forms when DMS breaks down. But they didn't detect it. That raises doubts. Could the DMS-like signal be something else entirely? There's also the possibility of non-biological sources, like maybe this signal comes from some weird geological or chemical process we don't understand yet, especially under Hycean conditions. So the takeaway is, yes, this is really exciting, but also really uncertain. It's a scientific maybe, not a yes, not a no, just a very interesting clue. Visual fade to dark with text. So what's next for K2-18b? Part 4. What happens next? Approximately 60-75 seconds. Background music, hopeful cinematic tone. Host, inspiring tone. So what now? If we haven't confirmed life yet, how do we get there? First off, scientists will continue using the James Webb Space Telescope to gather more data, especially during upcoming transits of K2-18b, when the planet passes in front of its star. More transits mean more atmospheric readings. Researchers will also reanalyze the current data with improved models, trying to rule out errors or find alternative explanations for the dimethyl sulfide signal. And beyond that, future telescopes like Ariel and Louvois could give us even sharper tools to study exoplanet atmospheres. We're just at the beginning of this era of exoclimatology, studying weather and chemistry on alien worlds. If we do detect DMS and confirm it with stronger confidence, it could be the first real chemical evidence of life beyond Earth. Not just speculation, not just science fiction, but science reality. Until then, K2-18b remains one of the most exciting mysteries in modern astronomy, and the hunt for life continues. Visual. Fade out to Earth rising over the moon, then text. Are we alone? Outro. Final thoughts and call to action, approximately 30-45 seconds. Background music fades to soft, inspiring tone. Host, calm and clear tone. So, is there life on K2-18b? We don't know yet. But the discovery of molecules like dimethyl sulfide, especially on a planet with oceans and a breathable atmosphere, brings us closer than ever to answering one of humanity's oldest questions. Right now, it's a scientific maybe. But that's how big discoveries start. With bold questions, careful data, and a whole lot of patience. If you enjoyed this deep dive into space science, make sure to like, subscribe, and hit that bell so you don't miss the next breakthrough. Visual end screen with channel logo, subscribe button, and suggested videos. Music swells slightly and fades out.